Hello guys, welcome back to my channel for the and today we are going to solve the question find median from data stream. Okay, so in this question we are given the median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is mean of two median value. For example, if it 2 3 1, so as you can see, this is an odd number of integers. Okay, so the median is actually the middle one, but whenever there is two element or the even element, then the sum or the average of both is taken. Okay, so here how we are going to solve this question. So let's see the test case. This is the median finder. This is actually a constructor, so this will construct the value. Then we are just adding the number. Okay, so here add number. So whenever there is add number, so there is nothing, it will just give us null as the answer. After we put find median, it will just find out the median, whatever the median is. Like here in this case we have even number of element. Okay, so 2 and 1 are the only thing that we contains, so the sum 2 plus 1 upon 2. Why we are actually doing the sum here? Because it is even number of elements, and whenever there is even number of elements, we are just going to find the median of both of them. So 2 plus 1 is actually 3, and 3 divided by 2 is actually coming out to be 1.5. So that's why here 1.5 is actually coming. And then we will just add now number, like it is 1, 2 and 3, and in this. And then when we find median, we can see that 2 is actually occurring at the middle. Okay, so that's how, that's why. So how we are actually going to solve this question is the main thing. So let me tell you one thing. If this is my stream of integers, like, right, if this is my stream of integer, where can I find if this is odd number of integers, and like, or not odd number of, or these are the odd number, like elements are odd. So where can we find the median? So median will be in the middle, right? We know this. And here it is n minus 1 or n. But okay, so if this is at the middle, right, this is at the middle. Why it is like this? Because as you can see, like, let me show you example. If this is 1 2 and 3, if this is 1 2 and 3, this is, as you can see, it is odd, and this is odd. At the middle we can see that okay, we are actually getting this and this, right? This is actually equal, so that's why I am just showing you how can we just observe with this. But if it is even, so it will be 2 2 2 2, right? So we can see that we are actually taking this one, and we are actually taking this one. So this means if we can divide it by half half, so that's why. And you can observe one more thing, that if this is the stream, like 1 2 3 4 4 5 and 6, right, and let's take 7. So if this is the median, you can see that all the elements occurring here and all the elements occurring here. So let's call this small because all the elements are small here, and let's call this large because all the elements are large here. So whenever we need to find small and large, we can see that actually all the elements which are to the left are actually smaller. So whenever we need to store the smaller value, and here it is 3, right, and here it is larger values, all the values are actually larger. And let's see another example, 3 4 5 6 7 and 8. So here you can see that it is actually on the division of 4. So here we can see that two elements we have to take. So this is the smaller group, and this is the larger group. So whenever I have to take the value, I am just taking the front of this, or the top of this, and the top of this. So how can we do this? So if we can see that this is the minimum, this is the minimum in this, and we know that if we want to take out the minimum, we can use a min heap. So here in the larger group we are going to use min heap, while in the smaller group, as you can see, we are just taking the bigger one. Okay, so whenever there is a condition of, whenever there is even number of element, we can say that what we can do, we are just going to take the smaller group. We are going to use max heap, and for larger group we are going to use a mini heap. So these are the two things that we have to keep in mind. And for the odd group, and for the odd group okay, for the odd group, if this is the thing, if let's say this is n, and this is n minus 1, obviously, because if we can add both of them, it will become 2n minus 1. And as you know that 2n minus 1 is actually denotes to the odd number, right? 2n minus 1 or 2n plus 2, whatever. So 2n minus 1 is actually odd. But from where we are actually going to get our median? So as you can see, if we take one element from n minus 1, it will become n minus 2. And this array is as we are not going to take anything, so this will become n. So as you can see, they are not equal. So this means our we can't take median, our uh, we can't take our mean from this n minus 1. So we are going to take mean from this n group, or the larger group, if the size is actually greater, right? N. Okay, so if we take this, it will become n minus 1, and here also it will become n minus 1, and it is in the middle. So that's why we can see that okay, we can when whichever size is bigger, we are going to take out the element from that only. Okay, after this I can say, after I can arise to a conclusion that if my this is small is empty, as well as my large is empty, I am going to push it into the small, and I am going to check if my this top is actually if my small top is actually greater than the nums that I have to put. I will just put it into this because it is actually less, right? I will put it here. But if it is greater than nums, then greater than nums of I, then I am just going to put it into the large because it is greater than the median value. Okay, so these are the conclusion that I will make. Now let's move to the coding part. As coding part is actually really simple after this explanation. So large, as I told you, this is a min heap. Okay, and small is actually the max heap, as I told you. After this, this constructor is called, and this add nums is actually where I am going to add the numbers. So I am just going to check either my small empty is empty, or my small top is greater than num. If it is greater than num, this means that it is going to get pushed into a small dot pushed. Else I am just going to put it into the large group. Then I am going to check if my small size is greater, because if my small size is actually getting greater and greater, I have to shift the elements into this large one, because we have to maintain equal size, or n minus 1 size, or n size. Because if anything will become greater, it will just cause problem to us, because we can't find equal number of, because we need equal number of here numbers of elements here and equal number of elements here. That's why I am just going to do this step in order to make sure that both group have equal elements. After this, we have to find the median, and in order to find the median, I am just going to check if my small size is greater. This means if this is n, and here the large size is n minus 1. So that's why, as I told you, that I am going to take element from this n. So that's why I am just going to take element from small. But if this is not the condition, I am just going to take the vice versa, or I am just going to take the element from large value. After, and if it is not, both of them is not true, then both of these is actually equal to n and n, right? And if they are equal to n and n, we know that this is a condition of even number. And if this is a condition of even number, then I can say that large top, okay, the large top, which is here, I am going to take both of them, and I am just going to divide it by 2 in order to find the average. Okay, so this is the thing. This is the coding part as well as the algorithm part. I hope you like the video. Make sure to like, share, subscribe for more upcoming videos, and thank you for watching.